So now let's look and see. We need to make one of these the ground. So this is another example on Supernode. And I try to put dependent sources here. Well, with the supernode, it says anytime you have a voltage source, you treat that node as a supernode. So this is one node. There's also a voltage source here. That is another node. We need to make one of these nodes a ground, and it doesn't matter which one. I usually pick the points with has the highest connection, the busiest point. And for me, the busiest point that looks like is this point, right? It has 4 junctions. This has 3. This has 3, 3, 3. I pick usually the one that has, well, it doesn't really matter which one, so I'm going to make this my ground. If that's ground, what is the voltage there then?
0.
That's 0. What's this voltage here?
0. 12. No.
Not 12. Negative 12.
But so you're not choosing the supernode as a whole. You're choosing just that.
Just that node, yeah.
Okay, but you can't ground the supernode.
No.
To 0.
No, that's not that's a negative 12 volts. Now, I can write them in terms of Vx and Vy if you want to. What do you think this voltage here? If you want to write in terms of 12, this number and that value.
Negative 12 plus Vx.
Negative 12 plus Vx, is that what you said, Jordan? Yep. Yes. It's whatever this one. No, it's plus on the top, minus on the bottom. That tells me this node is this much higher than this. So it's negative 12 plus Vx. What's this node here?
Negative 12 plus Vy.
Negative 12 plus Vy. And what's this node here? What's the voltage there?
Negative 12 plus Vy plus 0.2 Vy.
Good. It's this one, add to it 0.2. So negative 12 plus Vy, that's the bottom. Add to it this amount, because that's minus to plus. This end is 0.2 higher than this end. So if you simplify it, that's what? Negative 12 plus 1.2 Vy. The reason I rewrote them this way, how many unknowns do you have when you look at all the nodes? How many unknowns of them? 2, Vx and Vy. Guess how many equations you're going to have now when you solve them? 2 equations by 2 unknowns. If you call them V1, V2, V3, V4, then you will have what? 4 equations by 4 unknowns. So I try to write everything in terms of the stuff that was given to me. That eliminates a lot of the equations. Now let's assign currents and go in different directions. I'm going to assign, since Vx is going this way, I'm going to assign the current coming down this way. We'll call it I1. Notice that's plus to minus. I'm going to assign it going that way. I2. This one, it's really up to you which way you want it. Want to make it coming down or up?
Up.
Up, okay. I sub 3. That one, which way? You want it up or down? Doesn't matter.
Down.
Oh, we get up, we get down. I gotta make it sideways. I4. So I assign current without thinking about it. Go, okay, let's see which way. This is one node. Let's look at KCL at that node. At, we'll call it first supernode, this is the second one, right? At supernode 1. So you know which one. We're talking about that node. Again, KCL says if you add all the current going into that node, should equal all the current coming out of that node. What is going to that node? Let's look and see. I see I1 going to it. I see I2 going to it. I see I sub 3 going to it. I sub 4 is, where's I sub 4? No.
14's going out.
Oh, 14 is leaving and this one's leaving, yeah. I sub 1 going. I sub 2 going to it. I sub 3 going to it. And what's leaving?
14.
14 plus 0.5 Vx. Let's not waste our time. We know we're going to be writing these current in terms of the voltages. Might as well do the substitution now. What is I sub 1? Notice the direction of I sub 1. I have it coming down. So it's what? It's this voltage minus this. Well, this minus that, isn't that Vx? It's Vx over 0.5, which is 2 Vx. I sub 2. It's this voltage minus this, which happens to be Vy when you subtract them. Vy over 2.5. And I sub 3, that's going up. It's this minus that over 1. So if we come back here and plug in these values, I'll have one equation by two unknown, Vx and Vy. Then I'll do another one here. Then I should have my two equations by two unknowns. So what is I sub 1? 2 Vx. What's I sub 2? Vy over 2.5. What's I sub 3? Negative 12 plus Vy equals what? 14 plus 0.5 Vx. Multiply by 2.5 to eliminate the fractions. 2.5 times 2, 5 Vx plus Vy, 2.5, 20, is that 30? Plus 2.5 Vy, 28 and 7, 35 is it? Is that 1.25? Now let's put all the x's on one side, all the numbers on the opposite side. I will have 65 on this side equals 5 Vx minus 1.25. Is it 3.75? Vy plus 2.5. Oh, Vy. That's the first equation. So we did KCL at the supernode 1. And when you simplify it, that's your answer. Now I'm going to do KCL at supernode 2. That's this one. You love to see voltage source when you're doing nodal analysis. Because a voltage source, every time you see a voltage source, there goes one unknown. Because if this was a resistor, you don't know what that voltage is. It's not going to be negative 12. That will make it another equation. So when I'm doing nodal equation, I'm excited when I see a voltage source there. There goes one less equation. There goes another less equation. So now KCL at supernode 2. That's this node. Again, if you add all the current going in, should equal all the current coming out. What is going to that node?
0.5 Vx.
0.5 Vx. And what's leaving the node?
I sub 2,
I sub 3,
I sub 3,
I sub 4. Okay, let's go through it and see. Quickly, I sub 2, we wrote that early. That's this one, that's Vy over 2.5. It's this minus that over 2.5. I sub 3, we did that early too. It's this voltage minus nothing over what? 1. And what's I sub 4? It's this voltage minus that. So what do we have? When you subtract this minus that, is that 1.2 Vy minus Vx? Because the 12 will cancel negative 12.
Yep.
So it's 1.2 Vy minus Vx divided by 2. So it's this value here minus that value here. Subtract them. And the 12 will cancel each other out. And you have this value minus that. Now plug them in. 0.5 Vx equals I sub 2 Vy over 2.5. I sub 3 negative 12 plus Vy. I sub 4 1.2 Vy minus Vx over 2. My LCD for that is what? 5? 2.5 Vx, 2 Vy minus 60, right? Plus 5 Vy plus, this will be 2.5 times 1.2. 2.5 times 1.2. It's a 3. 3 Vy minus what? 2.5 Vx. If you move all the Vx's to one side, all the Vy to the other side, oh, you'll have what? 5 Vx? 2 Vy, 3 Vy, 5 Vy, is that 10? Move them to this side, that's a negative 10 Vy equals what? Negative, right? That's equation number 2. You have 2 equations by 2 unknowns. You're done. Right there. Solve them any way you want to. I'll go on my calculator here. Simultaneous. 2 equations. 3.75. 3.5. 65. Next one, 5. Negative 10. Negative 60. Solve it. I got Vx equals 8. Vy equals 10 volts. Now, if you want to find anything else, we can tell you what the voltage at every single node. If Vx is 8, what's the voltage up here? What's 12 plus 8? Is that negative 4? Vx is 8. Negative 12 plus 8 is 4. Down here, what's the voltage? Well, Vy is 10. What's 1.2 times 10? Isn't that 12? What's 12 minus 12?
0.
That's a 0 voltage here. What's this one? Vy is 10. What's negative 12 plus 10? Negative 2. I can tell you every current, everything about that circuit once I find these values. Let's try another big problem.
For the exam, we can't use nodal analysis if we.
You are going to use it, but you're only going to have one node. So you don't need nodal, it's KCL.
Yeah.
It is the same thing, it's called KCL when you have one node. Nodal is when you have multiple nodes. So let me take a bigger problem. Let me see if I can find something big. That'll be 4 equations by 4 unknowns. Yeah, that sounds good. 4 equations by 4 unknowns. Or maybe I can put some dependent and independent sources like we did the previous one. I'm trying to find for you some ugly one. Throw it in.
Hey Z, did you take modern physics when you were in the later years of college?
We had actually physics 1, 2, and 3, yes.
How was that?
I loved it. I was always fascinated with physics. So it depends if you like it or not, you know.
Gotcha.
Let's look at this problem. And it looks like here we go. It's not as big as I thought. Well, leave a space on the top because there's going to be another layer on the top. This is 45. Plus minus. And this is 5 times I sub 2. We have another source here, current source again. .02 V1. .30. That's ohm here. We have another voltage source here, plus minus 100. We have a 20 ohm resistor here. The voltage here is V1 because this current source depends on that voltage. Point 2, that's another dependent source, voltage source. Point 2 times what? V3. And where's V3 and I sub 1? Let's put 1 up here. This is 50 ohms. V3 is right here. And I sub 2, because I use I sub 2 as this current. I don't want I sub 2, why not I sub 1? Because there's no I sub 1 anywhere in the circuit. It's alright, just labels. So maybe I want to make them different colors so you get to see them. That's negative V1 here. Here we go. This, I'm not changing it, so I'm making it red color. Was it V1 here? Yeah. I want it to stand out. And where's the V3 up on the top? Because the value of these depends on minus plus V3. I want you to see it. I don't want you to miss it. And this current here, I sub 2. we can see them now. The biggest node I see here is the bottom one, right? So this is my ground, which means 0 voltage. Well, let's see. What is this voltage here? Yep. This one says that's a voltage source. This end is this much higher than this end. So if this is ground, this is 5 times I sub 2. Let's look at this. What's that voltage there? 0.2 times V3. And what about this one?
100.
What is it?
100.
100. What about this one? Well, that'll be here. Isn't that, well, if you look at this, we know what the voltage here is, 0.2 V3, right? I can call it Vx here, but then I'll have 1, 2, 3 equations by 3 unknowns, which is no big deal. It's not that difficult to solve, but if I keep my eyes open, notice this voltage here is what? 0.2 V3, isn't it? And this one says this end is V3 lower than that. So take 0.2, subtract 1 from it,
Why 1?
is 1 V3. So this end has to be what? Negative 0.8 V3? Again, you could have called it V1, V2. And you'll have 3 equations by 3 unknowns. I'm trying to eliminate the number of equations. Now I only have 2 unknowns. I see I sub 2 and V3s. See them on the nodes? That means I should only have 2 equations by 2 unknowns. But I'm going to go actually, I'm going to make it worse intentionally because maybe you didn't see that. But if you did see it, that's great. If not, you don't know, I don't know what that is. It's called Vx. So if you didn't see it, it's not a big deal. And now let's assign current in any direction that you want. I1, I2, I3. Oh, we have I sub 2, right?
Yeah.
So this is I sub 4. I sub 2 is this current. That's this one. Anything else? No. Okay. If I do KCL at Vx, .02, where's V1?
V1?
Oh, right there, yep. I was looking like, where's V1? So let's see, what is going to that node? The current going in equals the current coming out. What is going to it? I1, I2, 0.02 V1, and what's leaving?
I4.
I4. Usually we want to write all these current in terms of the voltages. Let's look at I sub 2. What is I sub 2?
Vx.
Well, isn't that the current this way? Isn't that this voltage divided by that resistor?
Oh yeah, that's right.
What's that voltage?
53.
V3 over 50. And what is I sub 4?
It'd be Vx minus 100 over 30.
Vx minus 100 over 30. Good. What is I sub 1?
5.
5I2 minus
5 I sub 2. Well, wait a minute. What's I sub 2 equal to?
Current, right? It's the voltage, right?
Well, it's going to be, so 5 times that number, right? Which is V3 over 10 minus this voltage is what?
Vx
Vx over
45.
45.
Wait, how's 5I1 V3 over 10 again?
How's what?
How is it V3 over 10 again?
Because I2 we solve as V3 over 50.
Oh, okay.
5 times that.
Yeah, okay.
So this fraction, if you multiply by 10, what do you have? V3 minus 10 Vx over what, 450? Now plug these values in. I sub 2 plus 0.02 V1 equals I sub 4 I think 450 is the LCD. It's divisible by 3 and divisible by 50. So you'll have V3 minus 10 Vx plus, what's 450 divided by 50? Is that a 9? 9 V3 what's that? Is that a 9 too? 450,
It's 9.
is it 9? Equals 45 by 15, that's 15 Vx minus 1500, I think. Maybe I should use a calculator, that'll make my life easy. It looks like we have three, four unknowns. I don't know, V3, Vx, V1. So let's write them. 9 V1. Bring that 10 Vx to this side. Is that negative 25? And 1 and 9, is that 10? Equals what? Negative 1500? That's equation 1. Now let's try KCL at this node. Want to do that node? The problem if you do that node, this is a super node. 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 So which one do you want to do? If you want to do one here, so you treat this as one node, all of this, and keep an eye. This attached to this. So we say the current end, you got to look at this end, look at that end too. And this end is that end. If you do this, the same thing. This attached to this. So let's pick one of them. Which one you want? You want to do KCL at this one? KCL at this? KCL here? All these attached together. So this is really one node. So this, or that's one node. That's the only option you have. So it doesn't matter which one you use, because that is the same node, supernode. So you want to do the far left or right? You said this one? That one? Doesn't matter. It's the same node. So here we go. KCL at 5i sub 2. What's going to that node? And you really got to keep your eyes open here. I'm probably going to need help with it. Now look at that node. Nothing going in here. But this is the same end. Is anything coming down here? No, that's leaving.
So it's
This is the same end as this. I sub 4 is going to it. I sub 3 is going to it.
But it doesn't matter where I sub 4 and I sub 3 are pointing technically, right?
They're going in, right?
They're both going into the.
So they're going to that
If it
end.
was flipped over, it would still be
It would still be
going in.
going in.
The I4.
I4 would not though.
Yep. And what else going to it? Is there anything else going to it?
Nope.
Nope. So this one all one piece. What's leaving the node?
I1,
I sub 1.
I2,
I2 is leaving the node. I'll take that. What else? I3 is leaving the node.
isn't I3 entering it? No.
It's entering this end, but it's leaving that one.
Oh.
There's some more.
0.02.
0.02 V1.
So the I3's cancel right away.
Yes? And now we plug these values back in. We know what I sub 4 and I sub 3 and I sub 1. We have them right here. I sub 4 is what? Vx
So that is probably good.
equals I sub 1 V3 minus 10 Vx over what?
450.
450. I sub 2, which is V3 over 50 plus 0.02 V1. Wait, does that look like the same equation? Let's see. Let's clean it and see what will happen. Is that 15 now?
15 units. 15 units. Same thing, right?
No, maybe. Let's see. 9 V1. How many VXs? Negative 25 Vx, right? And plus what?
Plus 10 V3.
Wait a minute. That looks familiar, doesn't it? Does that look like the same equation?
Yeah.
I got a problem. I can't do any more more KCL. So this is the same equation. Now I have same equation. How do you solve for V1, V3, and Vx when you only have one equation by three unknowns? Can't. So I got to start looking like, okay, V1 and Vx and V3. Let me take a look at V1. Well, let me look right here. What is V1? That's V1. What is V1? Can I write V1 in terms of either Vx or V3?
Yeah, V3, right?
Well, not really. V1 is this voltage, plus to minus.
Would it be V3, point two V3 to V3 minus 100 over 20?
Not over 20. Once you do over 20, that becomes a current. Right? I'm looking for a voltage. It's this end minus that end. So V1 equals 0.2 V3 minus 100. It's this voltage minus that voltage. So if I plug it into this one, I can shrink that now from one equation by 3 unknowns to what? One equation by how many unknowns?
2.
2. So let's do that. 9 times 0.2. Is that 1.8? Minus 900. So add 900 to this. What are you going to have? Negative 600. 1.8 plus 10. 11.8 V3 minus 25 Vx. We're making progress. We have one equation by 2 unknowns. We still can't solve it.
You have to get that VX.
So I got to find V3 in terms of Vx or Vx in terms of V3. Let me take a peek at it. Vx in terms of V3 and V3 in terms of Vx. Where's V3? Right here. That's V3, you see it? Plus on this end, minus on that end. That tells me that V3 is this voltage here minus this voltage here. Do you agree with that? It's this end minus that. Let's see what V3 then when you write it that way. V3 equals this voltage, which is what?
0.2 V3.
It's 0.2 V3 minus this voltage is what?
VX.
Vx. V3 minus is at 0.8? Or Vx equals negative 0.8 V3. Can you plug it in now?
Yes.
So we do that, plug it into this equation now again. Negative 600 equals 11.8 V3 minus 25 times in place of Vx negative 0.8 V3. Turn it on. 11.8, quit. Plus, because negative times a negative will be a plus. And I got 31.8 V3. Can I get what V3 is? It is negative 18.87 volt. If that's what V3, do you know what Vx is?
Yep.
Negative 0.8 times negative 18.87. Vx equals 15.09. And if I know Vx, can I find what V1 is from this equation? If I need it? 0.2 times V3, and V3 is negative 18.87 minus 100. Point 0.2 times negative 18.87 minus 100, and I get negative 103.77 volts. So I found V3, I found Vx, and I found V1. This was not my intention to end up with one equation by three unknowns. I just looked at the problem, so that looks like a cool problem. And it was cool, actually. I'll do another one. We have time for one more.
Supernodes, like all one node. All one supernode. How are they connected? Because the ground is all the same.
I understand that, but it seems like there's some amount of like the positive and as well. Unless I was looking at it.
And one negative, three positive ends.
Because they're all connected together, so.
Okay. Let's try another one with node analysis. I'll make this one a bit better. Like it's not that long because I only got 10 minutes. That's another example with Supernode. I start from the right side. I'm going toward the left. So start from the right. Point 0.5 times Vx. Ten minus the plus 5 here voltage source plus to minus 1 we have 9 ohms here. Plus to minus, that's the Vx. At 2 ohm here. Plus to minus 2. In the bottom we have 3 ohms. You can make any point the ground.
So you can make the center of the ground.
Okay. You want the center to be the ground? So this is my ground.
Isn't it easier when you have most?
Is it the most?
Yeah.
1, 2, 3, 4.
Yeah.
I could have made this the ground. Will make my life easy too, but it's not big. No big deal. You said that this is so. This is my ground. I mean that's 0 voltage here. What's the voltage down here? That's one node. What is that?
-1,
Very good. Why -1, Jordan?
because it's, polarity there is.
Yeah, this source saying this end has to be 1 lower than that. 1 lower than 0, which is what? -1. While I'm at it, what's the voltage right here? This is another node.
-6,
This one says this end has to be 5 lower than this. If this is 0, what's 5 lower than 0? -6. So these are good. These are voltages, so there's no unknowns here. I'm in good shape. What about this end? Nobody knows, right? So we'll call that V1. What about this end? Does anyone know what the voltage here? How about V2? What about this node? V2 plus 2, very good. You don't want to write V3. That means add another equation. We have one more node. And that's right here. And what's the voltage there?
VX.
I'll take the Vx. Because this one says what? This end has to be this much higher than 0. Vx higher than 0. So that's Vx. So if you look, how many unknowns do you see there? I see V1, V2, and Vx. How many unknowns? 3. 3 equations by 3 unknowns. This is a supernode. We'll label that as supernode 1. This is supernode. This is a supernode, but since they're attached together, this is really one node, just like the previous example. And you can assign current any direction that you want. This node becomes silly because all that tells you what? That this current equals what? Itself. It's going to go through that. So that equation, if you do KCL of this node, it's not much of help. You say this minus that over 2 equals this minus this over 9. Same current going through it, there's no way to exit. So where should we label this current? High 1, okay. How about here? Which way you want the current?
Left to right.
Left to right? This is the left, that's the right. Okay, I have to think here. I sub 2. And what about this one? Which direction? Technically left to right. Why? This is 0 voltage, that's negative 6. Oh, what about this one? I forgot about this one, the bottom.
Right to left.
Left to right, you said?
Right to left.
Right to left? Okay. Direction doesn't matter. Just make an assumption, stick with it. Now I'm going to do KCL at each node. Should we begin with the first supernode?
Can we start with the biggest one?
You can. You're going to need 3 of them anyway, so it doesn't really matter where you start. But you want to start with the biggest one. I'm assuming you're saying this is the biggest one, right?
Yeah.
So remember now, this is one node. Since this is the same thing, that's really all one node, right? So if I have a highlighter here, which I do, I think I have one here.
Isn't I4 just I1?
Which one?
I4 is
Because
just
that's
I1.
I sub 4. This is one node. I sub 4 is going to equal to I sub 1. Yep,
Yeah.
it will be. That's what's going to tell us. Yeah. So, you want to start with this one, you said?
Yes.
Okay.
Yeah.
So this is one node. All of this is one piece. Ooh, made it messy now. Doesn't look pretty. But that's one node. So KCL at the big node.
Big supernode.
Yep. That's this one. What is going to that node?
I3 is going to that node.
I sub 3. So here we go. Current in, current out. Go into it. You said I sub 3.
I sub 2.
I sub 2.
What is that? Is that V1, the current going into it?
This one?
Yes.
0.5 VX.
0.5 VX.
There's one more I see going to it. Keep looking.
I said 1.
I sub 1.
Yep.
Isn't I sub 1 going to it? This current is going to keep going, keep going, keep going. We said this current here, I sub 1, when you enter this one, still coming out of this is I sub 1. There's no branch for it. So I sub 1 is going to it too.
So it just bypasses that rather resistor?
Well, you can use this one, you can use that. It's going to, this one is going to equal to that one.
Cancels out.
And what's going to leave that node?
I4.
I sub 4.
I sub 3 again.
And what's leaving? I sub 3, yep. Now if you look closely at this node, let me take just a quick look at this node. Before this, KCL at Supernode 1. That's this one. That's I label that one. What is the current going in? And what's the current leaving?
I sub 4.
I sub 4 going in, and what's leaving?
I sub 1.
Right? So I sub 4 equals I sub 1. So if you look at that equation now, what's going to happen to I sub 4 and I sub 1?
They cancel.
They cancel. It's the same current. And I sub 3 is going to cancel I sub 3
So I sub 2 is equal to 0.5 dx.
with negative.
Negative.
Yep. So what's I sub 2? Where's I sub 2? I sub 2 is this voltage, which is what?
V1.
V1 minus this voltage here, which is what?
Negative 6.
Negative 6 divided by what? 10 plus 0.5 times Vx is equal to what? 0. Multiplied by 10. V1 plus 6 plus 5 Vx equals 0. That's equation 1. I need another equation.
For V1, right?
If you look at that equation here, where was it? We said I sub 2 plus 0.5 Vx equals 0. Why? Because that's KCL at this node. If you do KCL at that node, what do you have? What's going in?
Nothing's.
What's leaving? This and this.
And that, yeah.
That's what we have here. So you can't use that equation. I already used it on the big node. I can't use this one. I already used it here.
Wait, does it mean the current's the same at those points?
Which one?
The big node and the V1?
The big node.
The big node and V1, does that mean the current's the same? If it's the same equation?
This current?
Yeah.
This just saying this current coming down is the
You
same.
mean the voltage, I'm sorry.
Here?
Yeah, the voltage at V1 and the big node is the same.
Well, the voltage of the big node, it changes from end to end. Notice it's 0 here. It's negative 6 here. It's negative 1 here. So this might be treated as one node, but the voltage added, it changes from spot to spot. So I used this one, because you can see that's this equation. It becomes the same one. That's useless. I already used the big one. I already used this. The only thing left is that node. That's the only node that I didn't use. So if you want to write KCL at this node, maybe that will give me a second equation. If not, I got to start looking. I got to look for something else. So let me try that. KCL at Vx, right here. What's going in? It's this current, and that's what? This voltage, V2 plus 2, right? Minus Vx divided by 2 is equal to the current leaving, which is what? This voltage, Vx, minus 0 divided by 9. I'm saying this current going in is going to be the same current leaving. What's my LCD here? 18. 9V2 plus 2 times 9, 18 minus 9Vx 2Vx. Let's do the math. Take the 9 there and the 2 there, that's 11Vx minus 9V2 equals what, 18? If I move them to the right side. Let me take a peek here. Oh, I made it worse. Now I got V2, Vx, V1, 2 equations by 3 unknowns. I need one more equation.
What if you solve, try something for V2?
I need to find Vx in terms of V2 or V2 in terms of Vx or V3. One of them. Well, let's take a closer look and see. Let's look and see.
What about just V2?
What about V2? This voltage here.
Could you, like, without taking the Supernode, look into V2, or?
You can look at the V2. I'm looking to see how it's going to help me. I know this is Vx. Maybe I can find, let's see. I got Vx and V2, 2 equations. Well, let's take a look at Vx. That's this one. You go, well, that's this minus that. Not much. Let's take a look at V2 here.
You have I4 going in.
That's one node here. We already used that node. We already used this node. The current in equals out. We already used that node. That's this node, so the same one. That's this node. So I use them all.
So you can't solve this?
Well, I'm sure we can. We just got to keep looking and see if we can find anything. Well, let's look at this current here. Vx. Isn't that the same current coming through this? That current coming down, where is it coming from? Coming from that end. So let me zoom in on that picture right here. Are you with me? Here? Let me zoom in on that. This is what I'm seeing. I don't care about the rest of it. I have 0.5 Vx. I got V1 here. What's the voltage here? -6. And if I define the current coming down this way, what is that current equal to? Better be that current. So
Wouldn't it be -6 though?
I'm just right in terms of this one.
Oh, okay.
This current coming down better be that one. There's no other branches. So this current here, the 0.5 Vx, the way I labeled it going this way, must be, because I labeled going this way, this voltage minus this one, divided by that resistor, which is what? 10. So it's -6 minus V1 divided by what? 10. Multiply by 10. 5 Vx equals -6 minus V1. 5 Vx plus V1 equals -6. And what do you know? Now you get your third equation. Equation number 3. Here's my 3 equations.
So
Oh, look at this.
Can you slide that up a bit?
Yeah, can you move that up?
Doesn't matter.
can you slide it up a little bit?
Look what happened. Oops.
Well,
Oh, well.
I guess we just throw it all away. Alright.
Can't use it.
Sucks.
What else? Keep looking. Let's see. What else do we know? What else do we know? We know what this current is, I sub 3. That's what, 0, that's 6 over 10, which is 0.6. .5 Vx, yeah, I sub 4. Negative 1. We did that equation, right? The current in equals the current out. Let's write KCL here and see what will happen. We established I sub 4 equals I sub 2, but let's do an equation and see what's I sub 4. We said I sub 4 equals I sub 1. What is I sub 4? Isn't that negative 1 minus V2 over 3? Right? That's the current going in. And what's the current leaving? V2 plus 2 minus Vx over 2. LCD is 6, right? Negative 2 minus 2V2 equals 3V2 plus 6 minus 3Vx. Can we clean that? Negative 8. Because you're going to need that equation. That's actually going to be the one you need. And what do we have here? 5 equals, not plus, equals. Isn't that 5V2? And what? Minus 3Vx. Do you have that equation yet?
No.
That's your third one. So a lot of times you start doing them, you realize, oh, it's the same equation. You know? Keep looking. KCL at each node. So now I got my 3 equations that I need. Here's one of them. Let me write it down while it's fresh in my head. I'll put V1 first. So 0V1 plus 5V2 minus 3Vx equals negative 8. This one, V1 plus 0V2 plus 5Vx equals negative 6. And the last one, this one, 0V1 minus 9V2 plus 11Vx equals the 18. How many equations by how many unknowns? 3. And now we are golden. Zero, 5, negative 3, negative 8, 1, 0, 5, negative 6, 0, negative 9, 11, 18. Solve. V1 equals negative 9.21. V2 equals negative 1.21. And Vx equals 0.64 volts. Voila.